All right, guys, so this is our second translations video, okay? Just a couple things I need to show you about translations, okay? Um, and so I'm getting everything ready here. All right, let's get this pulled up. Let's go. Oops, didn't mean to do that. And let's do this. Here we go. All right, so just follow along your notes, okay? It says, so continuing our discussion on translations, it says a rule. Well, let me get it on the pen and in color so you can see it. A rule can also be given that tells me how the translation is being performed. Now, this rule appears as a number being added or subtracted to, this should say to or from, but this is fine, to both the x and y coordinates. Okay, so we have a rule, and a number is either going to be added or subtracted from the coordinates. Okay, now when we look at the x coordinate, if a number in the rule is added to the x coordinate, that means the x coordinate of the pre-image will be moved to the right, and that new coordinate will be the x coordinate of the image. Okay, if a number is subtracted from the x coordinate, that means the x coordinate of the pre-image will be moved to the left, okay? Just like a number line. If you add to the x, it moves to the right. If you subtract from the x, it moves to the left. It's as simple as that, okay? Now, when a y coordinate, if a number is added to the y coordinate, think of an elevator. That means the y coordinate of the pre-image will be moved up. If a number is subtracted from the y coordinate, that means, this should be together, sorry about that, that means that the y coordinate of the pre-image will be moved down. So it's thinking of an elevator, okay? Sometimes nothing will be added to either coordinate, and we'll see an example of that. In other words, it'll just be x or y. That part of the rule means that that coordinate will be the same as the coordinate of the pre-image, okay? So there will be a rule in which a number is added or subtracted to each coordinate, and that's going to tell us what direction to move the vertex for the image, okay? Okay, so let's see what that looks like. Now, this isn't drawn out, but we can just look at what this rule is telling us, okay? It doesn't matter what the triangle is. It says translate a triangle by the following rule, x minus 5, y plus 3. This particular rule means that I'm going to translate this triangle, each vertex, 5 units to the, now this is a subtraction sign on the x coordinate. So that means it's got to move to the left 5 units, and the plus 3 is attached to the y, so that means every y coordinate is going to be moved. That means 3 units up, okay? That's how we use a rule. Now, with that being said, if I'm comfortable with adding or subtracting integers, you don't necessarily have to graph the pre-image unless you're told to do so. You can apply the rule through the addition or subtraction to the coordinates given for the pre-image to obtain the image. Okay, let me say that again. If we're comfortable with adding and subtracting integers, we don't have to graph the pre-image. We can use the rule by adding or subtracting to the coordinates that are given for the pre-image to obtain the image, okay? And I'm going to show you how to do it both ways, all right? So if I go to this example, we're going to put it all together, okay? So I'm going to change to black on the ink here. I think I'm going to move this over here for right now because I'm going to use several different colors. Now it says rectangle WXYZ with vertices, blah, 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 blah. So I'm going to graph this. So it says W is at negative 2, 2. And this is a little hard to see, I admit, but there's the origin, okay? Negative 2, 2. So negative 2, 2 left and 2 up. And that's W. X is at 1, 5. 1 right and 5 up. Y is at 7, negative 1. So 1, 2, 3, 4, 5, 6, 7, negative 1. Okay. And you might want to go along with your pencil and just kind of draw a little darker the x-axis. Okay. This is the x-axis. And then draw the y-axis a little darker. So it'll be a little easier to count and see. Okay. And this is the y. All right. Now this x and y doesn't have nothing to do with the vertices. Those are just the axes, okay? Then the y vertex is at 7, negative. So this is y. That's the vertex. And then 4, negative 4. So 1, 2, 3, 4. 1, 2, 3, 4. And now it's just that's z, okay? And now I just play connect the dots, all right? Okay. All right. So that is the image now. Now to apply this rule, this is telling me x minus 1. It's telling me to take every x coordinate and subtract 1 from it. That's what I'm being told to do. And then to take every y coordinate and subtract 4 from it. Which if I subtract 1, that means you move 1 to the left in the x direction. And for y, if you subtract 4, that means you're going 4 down. And you might want to write that down so you can keep track of everything that's going on, okay? Now I'm going to use a different color so we could clearly see the difference, okay? And I'm going to erase all at least this part up here. There we go. So it won't look so cluttered. Okay, so if I take negative, so if I take, and I don't even have to look at these anymore, okay? But I can take negative, I can take each vertex and move it 1 left and 4 down. So 1, 1, 2, 3, 4, and that's x prime. And then 1, 1, 2, 3, 4, and that's w prime. And then 1, 1, 2, 3, 4, and this is y prime. And then z would be 1, 1, 2, 3, 4. And this is z prime down here. And now again, I just play connect the dots. And this is why I use different colors, because sometimes the shapes overlap and it's hard to see what is what. Okay. And there's your new shape. Okay. And it should look like the first shape. If it's a triangle, you shouldn't get a rectangle. If it's a rectangle, you shouldn't get a triangle. Okay. Now over here, I need to list the coordinates of w prime. So remember, this is the origin right here in the middle. Let me go back to, let me try red now. This is the origin right here. Okay. So if I count over 1, 2, 3 to the left, which is a negative 3 from the origin. And then you move 1, 2 down, which is a negative 2. Okay. And then x is, you don't go anywhere in the x direction. So that's 0. And then it's 1 up. So this makes this just a positive 1. And then for y, it's 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5. So it's a positive 6 and a negative 5. And it may help, to write your signs. Remember, we talked about that to help you remember which is which. Okay. So when you look at y prime, oh, the x is positive and the y is negative. And then z prime is going to be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So 3, negative 8. Okay. Now, I could show you that I don't have to draw both shapes, okay? Well, I'll show you that on the next one. But I want to show you that I can say, well, if W is at -2, comma 2, these are the X and Y. I'm being told to subtract 1 from the X and to subtract 1 from the 4. Now, these aren't coordinates. This is what I'm doing to the coordinates. And so if I treat this as like an addition problem, and then you get W prime, -2 minus 1 is -3. 2 minus 4 is -2. And you can see these are the coordinates that I have written down here for W prime. And you could do that with all of them. So X is at 1, 5, okay? You're being told to subtract 1 and to subtract 4. 1 minus 1 is 0. 5 minus 4 is 1. And if you look at the coordinates that I have for X prime, or X prime underneath, this thing's being funny here. Those are the coordinates I have for X prime. So either doing it mathematically or visually by graphing it, either way you get the same answer. So what I'm going to do on the next one, I'm not even going to graph the pre-image. They give me the coordinates of the pre-image, right? It tells me to apply this rule. Now, this is one of what I was talking about. When it's Y by itself, that means it's going to be the same as the original, as the pre-image. I don't have to do anything to it. There's not a number being added or subtracted. So I'm going to go ahead and write 5 for G prime, and -2 for H prime, and -1 for I prime. Okay? And now all I got to do is take care of the X coordinates, because it's telling me to add 6 to all the X's. So -7 plus 6 is -1. So the X coordinate of G prime is -1. H is -4 plus 6, which is going to be 2. That's the X coordinate for H prime. And then I is -8 plus 6, which is -2. And now I'm going to graph the image. And again, it's a good idea to go through and darken these X and Y axes. They're the ones with the little dots at the end, okay? They're supposed to be little arrowheads, but it's so hard to see, okay? So I know here's my origin, okay? So from the origin, G prime is -1 and 1, 2, 3, 4, 5. G prime. H prime is +2, -2, which is here. This is H prime. And then I prime is -2, -1, which is right here. Don't forget to use those prime marks. And now you just connect the dots, and that is your image. Now, it's not the pre-image, it's the image, okay? And that's how you use a rule. You can either do it by graphing both, or you could do it mathematically and just graph the image, okay? Now, sometimes, and we already saw this in class yesterday, or today, I should say, but sometimes you'll be given the coordinates of or a shape that's already on a graph and another set of coordinates or a shape on a graph. And they'll be asked you to write a rule. That's what this says. This parallelogram is really a rectangle, but it has vertices here. And then the parallel, which is remember, with no prime marks, sorry, with no prime marks, that means this is the image. I see, even I got it wrong, sorry. This is the pre-image. Pre meaning before I do anything to it. Then it tells me parallelogram A prime, B prime, C prime, D prime, which is the image because it has the prime marks, has the vertices here. And then it says how many units was it translated in each direction to A prime, to go from this to this, to go from the pre-image to the image. And then it says write a rule. That's really what they want me to do. Okay. So let's graph. I have 2, 5, 4, 5, 4, 1, 2, 1. And then I'm going to have 5, -3. I'm writing this down so I don't have to bounce back and forth between the screens here. 7, -7, and 5, -7. So, oops. All right, there we go. All right, so I'm going to graph, and I'm going to use blue, the image, okay, which was 2, 5. So here's the origin. So 1, 2, 1, 2, 3, 4, 5. And this is A. And then 4, 5, which is going to be here, which is B. If you need to, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. And then 4, 1. So 1, 2, 3, 4, 1. This is C. And D is going to be here. And then just connect the dots. Okay. This is the pre-image. And you could put a little P there if you want to tell you, hey, this is what I'm starting with. Now, the rule says, okay, I want you to take that. I'm sorry, it's not a rule. Now they give me, I'm going to graph the image, which is going to be 5, 1, 2, 3, 4, 5, -3, 1, 2, 3. And this is A prime. And then 7, -3, which is here, which is B prime. And then C prime is 7, -7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And D prime is here. Now, when it's a triangle or a rectangle or something, you can always count to see that it's the same size. So A to B is 2 units. 1, 2. So is this. This is 4 units. 1, 2, 3, 4. So is this. Okay. It stays the same. So this is the image. So the question was, which I'm going to use black now, how many units is it moved from here to here? Well, all you got to do is pick one vertex and count. So I'm going to pick vertex B. So when I look at vertex B, it was moved 1, 2, 3 to the right. I'm going to write that down. And then it was moved 1, 2, 3, 4, 5, 6, 7, 8 down. Okay. Now I could do that for each vertex, but I know these are the same size. So if C is 4 away from B, then C prime is 4 away from B prime. The rule applies. Okay. I could prove it with, let's look at D, right? So 1, 2, 3 to the right, and 1, 2, 3, 4, 5, 6, 7, 8. So I proved it with 2. So the other 2 has to be true. Okay. So the rule is we know if we go to the right on the x-axis, that's in a positive direction. And we know that if we go down on the y-axis, that's a negative direction. So this means I took the x-coordinates of the pre-image and I added 3 to them. And I took all the y-coordinates of the pre-image and I subtracted or moved them down 8. And this is the rule for this particular translation. And guys, that's all there is. Okay. And that's what I mean by a rule. I could have done this mathematically, though. I do want to show you that real quick, and then we're done. So if I go back here, I can say, well, for example, if I look at this x coordinate and this one, I say, well, there's a difference of +3. And I can test that with all of them. Okay. So again, I can see +3. I took all the x coordinates and did +3. Then and I'm going to, well, I'll do it in yellow. I don't want to confuse. I look at the y coordinates, 5 to -3, and this is where you got to be good with positive and negative numbers, is -8. And again, 5 to -3 is -8. And then 1 to -7 is -8. And again, it's -8. So I took all the y coordinates and I subtracted 8 from them. So it's the same rule that I got from graphing. So one is mathematical and one is by graphing or visual or however you want to call it, okay? And that's all there is to it. That's the last thing I wanted to show you. When you have a rule, how to use the rule and how you can figure it out both mathematically and graphically. And we'll have practice on this in class tomorrow. And I hope you guys have a good night.